let's dive into how you manage legacy code. So there's some points to make about legacy code. It's probably not that well defined within the industry, but it's essentially code that is field proven. It might be old. Essentially it has been existing in products in the past, so it has proven its ability to handle at least in a certain mode of usage. What we can also say about legacy code is that more than likely it doesn't meet the latest coding rules that you may have in operation. But the other point you'd certainly make about it is that it is risky to go and fix issues in legacy code. The problem being, of course, that you introduce testing requirements whenever you touch code. You run the risk of actually creating more problems than you solve by trying to address code issues. And the other thing I would say about legacy code is that it isn't often or always separated into separate modules. I mean, here we can see that we can highlight that a module might itself be legacy code, but just as likely legacy code is actually entire files within an existing module or project, and it can even be individual functions within the module that perform a particular algorithm and have done so safely and happily in the past. So in terms of looking at legacy code and just giving another quick observation to it, I'm going to take us back to QA Verified just to show you how legacy code might be dealt with in a quality management system. So here I have to, I suppose, start by explaining to you that I'm looking at a different project right now. The project I'm looking at is called CGI. It's actually public domain software. And I have I suppose a decade's worth of versions of this project loaded up into my QA Verify. So you can see here I've got different versions loaded up. I've created an arbitrary branch point which helps to serve the purpose I'm trying to display here. So even though these are actually the same versions, I've sort of constructed a branch point, and I've created a fairly long sequence of versions on both branches. If we look first of all at version 3.02, for example, and over here we look at the types of issues that I have collected up. These are all basically issues from static analysis, and in fact using the QA C++ tool. I have two sets of issues loaded up here. One of them is the MISRA C++ rule set. So I in fact have the full MISRA rule set configured and applying to this project. I could equally have subsetted MISRA and just chosen some key rules, but I have what I'm looking at here is a whole set of messages mapped to rules within MISRA. And I also have a number of what I consider to be quite important residual defects in the code. So these are all grouped according to different categories of message in the QA C++ tool, and they cover a range of language usage issues and quite rugged data flow analysis type issues, which some of which match up with MISRA, and in fact some of them are just other very interesting issues to be observing. The main point though is that we have 1,400 messages in total against this project. So obviously, you know, as a project that didn't start out live or didn't intend to try and follow MISRA in particular, and possibly didn't have the ability to examine some of these residual defect issues, that's still quite a large number to have to manage. But in terms of legacy management, the main thing I've done in this project is this particular version 3.10, which I'll move on to right now. I've actually used that as a baseline. So what I've really done is I've said to my quality management system here that I am now baselining on this version 3.10. You can see it up here actually. And as a result of it being a baseline, well, actually I get 0 issues against that particular version. So I have basically decided to hide every issue that occurs in that version of the code. So if I step forward from version 3.10 into the next version 3.11, I'm now seeing only the issues which do not correspond to existing issues that existed in 3.10. And I'm using the techniques that I described in the very simple example I just presented earlier. So actually, if I go to my file view, I actually see, of all the files in this project, I actually see only a couple of very detailed issues cropping up. So if you could imagine that this was your project and you had baselined on this version 3.10, and today you're looking at version 3.11, well, we actually only have 3 issues to go and look at, which is a very targeted way of analyzing and viewing your the particular issues that you need to go and focus on. So some change was made to this particular file, and I'll go into my file compare to view this. Actually, what the change that was actually made was that some constructor and destructor declarations were added in, or inline definitions, in fact. And as a result of that, of declaring a destructor, in fact, particularly declaring a destructor, the tool is pointing out that we didn't also declare a copy assignment or copy constructor, which is good messaging to see, but it's also very targeted. It means that we're looking only at a very small number of issues. As we go forward, and if you observe the numbers up here, we're only looking at 8 issues as we step forward from version 3 up to version 3.13. And as I step forward in time, again, I will point out that none of these issues were actually dealt with in the ongoing development of this particular code base. But I think the point is well served that, you know, if you actually track the new issues that occur, you give yourself every chance of at least fixing any new issues that, you know, need to meet your full compliance type rules. So just looking at that legacy code management in summary, and I've kind of focused on one aspect of it, but there are some broader issues that a good static analysis and quality management system can help you with here. The first kind of general point is that you absolutely can triage legacy code and decide that it is suitable for reuse or that it needs to be refactored. And a good static analysis solution combined with architectural analysis and indeed your set of unit tests can give you this information to decide what level of quality your legacy code actually has today. You can also use a good quality management system to produce a targeted focus on various categories of issues. So you could focus on portability, or you could, as I could do in my tool here, you could choose to focus literally on the eradication of any dereferences of null pointers. So I can see all my null pointer issues in the code and decide that I need to do something to make sure that those issues are all dealt with. And the last point, which is the one that I suppose I try to explain in a little bit more detail, is that you can obtain full compliance on any altered code lines within your code base if it contains legacy code. So you can, every time you touch code, you have the opportunity to go and make it fully compliant. And all you need is a tool that will expose those issues in isolation so that you can actually focus on them.